So in my talk, I'm going to talk about how the attackers view your Salesforce landscape today. How do they actually work through the potential attack? How does that actually work? I give some real-life examples as well. And then I'm going to talk about what do these agents actually mean for security, and whether or not there are some challenges with that as well. It's a relatively short talk. I could talk about these topics for hours. So if you have any things that you want to dive deeper into, let's have a discussion after the talk, and I'm happy to dive deeper. I'm going to be talking through this using an attack chain. So how a typical attack in Salesforce would work. So relatively simple attack chain. But the reality is that businesses that use Salesforce rely on Salesforce for their business critical operations. So if there is some sort of a problem with Salesforce, it's going to disrupt the whole business. And this is why Salesforce security matters. This also means that availability is very important in Salesforce. So if Salesforce is down, the business stops. But today, in real-life attacks, the attackers are usually not after this. Not today, maybe in the future. But today, they are more interested in the data. And even though the data has a lot of value to the organizations themselves and their customers, because it's the customer data, like they don't necessarily want to have the data for the data's sake. They want to have the data because it has value to you and your customers, because they want to extort you. They want to get that data so that they can send a ransom letter saying that unless you give X million dollars, this data will be out in the public, and that's basically how many of these attacks today work. So it's sort of like a deviation of the ransomware scheme. There are of course other ways how an attacker could use Salesforce if they get access to it. For instance, well, we've probably all received phishing emails that have been sent from Salesforce, because those mails tend to bypass spam filters. And for instance, the attacker might be looking for Salesforce org so that they can send out those phishing emails that might be of value to them. But maybe still the biggest threat today, as I see it at least, is that the attackers are after the data in Salesforce. And just how do they get to that goal is, and here I've simplified the kind of the attack chain into 3 steps. The first step is initial access. In order to get to the data, they first need to get into a Salesforce org. This may not always be about getting access to the org where the data actually is, and I'll talk about that in the next step. But they need to get initial access into a Salesforce org. They can do this in many different ways. One is, of course, the traditional way of either guessing a password or using a password that was leaked in some other breach. So it's quite common that users, even though they are not, they are told not to, they quite often use the same password across different services. And then when one service gets hacked and the password gets leaked, that password can be used to log into other systems with that same email address. This is still very common. It's an attack called password stuffing. And then there are malware info stealers. So malware on laptops, be they Windows or Mac, can steal passwords from the browser when the user is typing them. But maybe more seriously, they can steal the access token from the browser. So basically the cookie. And the reason why that is more serious is that while MFA protects against these sort of password reuse problems or stealing the actual user password, if the attacker steals the authenticated cookie from within the browser, it actually bypasses the MFA until that cookie expires. Then data can also be accessed through vulnerabilities. And it's not uncommon, and you've all read about these cases also, that when companies expose their data through Experience Cloud, for instance, or they create Apex code that exposes an API or something like that, there may be mistakes with authentication. So some data that wasn't supposed to be available to everybody suddenly is available to everybody. And again, the attackers might read that data and then extort with that. And then, of course, insider threats. Somebody might sell access to their own Salesforce account. And phishing. There might be an email. You click on it, and there is a Salesforce login. You type in your username and password, but it wasn't actually Salesforce login. So these sort of things. But these are kind of probably something that you have all learned about in security awareness training. Something to be mindful of also is that in Salesforce, it's very common that Salesforce is integrated with other systems. So a third-party service uses a connected app to connect into Salesforce and act on behalf of the user, writing data. These third-party services will have an OAuth token, and they will have to store that OAuth token someplace. And usually what they do is that they have a database and they store all the OAuth tokens in that database. And by default in Salesforce, these tokens never expire. If an attacker breaches a third-party service and they access this database with the tokens, they can read those tokens and use them to log into the Salesforce instances that those tokens belong to, until those tokens are revoked. And the risk here is also that the company might not even using that third-party service anymore. Maybe they were using it 5 years ago and they had forgotten about it, but the token is still there in the database. Here are a couple of examples of for the last couple of years of services that have been breached in this way. Heroku being one of them and Sisense being another. A typical Salesforce org has dozens, maybe even hundreds of different services connected to it. At least there are many dozens of connected apps there. So you can think about what is the risk that, for instance, over a period of 12 months that one of those services suffers a breach. I don't know exactly what the risk is, but I just know that it's not zero. So this is one threat to take into account. But anyhow, initial access can happen in many ways. So after initial access, the attacker has access to one account in one Salesforce org. That account may be an admin or maybe a restricted user. That org may be just a sandbox or maybe a full org, a production org. So once the attacker ends up having access to the org, next thing that they will do is that they will look around. They will figure out, what can I do with this access? They may straight away go into exfiltrating all the data from the system, but typically what they do first is that they think that, okay, now I'm here, can I get to somewhere else from having access to this account? Can I elevate to an admin account? Can I get access to some other Salesforce org? Can I maybe get access to a third-party system? And there are ways of doing this. This is what in Salesforce circles is called, what in security circles is called lateral movement. And this lateral movement also exists in Salesforce. And And there are multiple things that can be used for lateral movement in Salesforce. One of them, and maybe the best example, is named credentials, or the older versions of that same technology. So basically hard coding credentials into Apex code or Lightning Web Components, or maybe storing them in some objects in Salesforce. But anyhow, Salesforce, in order to make callouts to external services, usually needs to have some sort of an API key or OAuth token or username password, something somewhere in Salesforce. And often the users may have too wide access and can actually read those secrets. And even if they cannot read them, they quite often can still use them. And the problem is that, for instance, if you integrate Salesforce with GitHub and you implement the named credential in a way that gives access to all of GitHub and not just the path where you need to give them access to, they can, for instance, create new users in GitHub from Salesforce. And this then leads into a breach of the GitHub account and not just the Salesforce account. So this is what we call use the word lateral movement with. Other examples, and I hope that this doesn't happen much because it shouldn't happen, but Salesforce has Trailhead. Everybody who's in the Salesforce ecosystem uses Trailhead. It's a learning platform by Salesforce, and there you collect all your badges and all that. It's wonderful, and it's very easy, but it has one security risk, and that is that when you have access to a Salesforce account that gives access to a Trailhead account, you can log into that Trailhead account. And if you've connected other orgs to that Trailhead account, there is a feature called hands-on orgs, so that you can actually log in from the Trailhead account to those other orgs. So again, moving laterally from one org through Trailhead account to another org is possible. And this is why I definitely would say that nobody should ever connect any company production or sandbox orgs into Trailhead, only those Trailhead orgs. Similarly, Environment Hub can be used for this, because Environment Hub in Salesforce is used for creating development orgs, spawning out scratch orgs and things like that, so that you can use for development. But you can also use it to map users between orgs and set up SSO mappings. So Environment Hub actually allows logging from one org to another. So if the attacker gets access to that, they can access those orgs that have been mapped. So there is a risk that compromise of one org will lead into compromise of other orgs that way. And then there's the virtualized data, which is very popular in the Salesforce world today, for good reason. There is, of course, Data Cloud, which is the new technology. So when you have access to a Salesforce org which has Data Cloud and you have the right permission set, you can actually read data from a data lake, something in AWS, maybe Snowflake. You can read that data just by accessing a Salesforce org. The older technology that can do the same thing is the OData, so cross-org connectors and all that. So these sort of external objects, which allows to do the same thing. So they don't give you access to the other system necessarily, but they give access to the data in the other system. So these are the kinds of things that in Salesforce contribute to lateral movement. So now the attacker has gained access to a Salesforce org, and they have moved laterally as much as they can. They have looked around like, okay, what can I do with this? They have seen that, okay, I can access this data, that data, that data, that data. Then they plan out, okay, how do I get this data? How do I exfiltrate the data? How do I export the data from those systems into into my system so that I can use it for this extortion attack. And there is quite a lot of this data in many orgs. So it takes a while to export all the data, as you very well know. So the attacker wants to do this in a way that doesn't trigger all the alarm bells possible. So they will want to figure out some sort of a relatively stealthy way of doing it. Something that looks like relative normal activity. So this is called evasion. Here is an example. This is a report from Google Threat Intelligence, earlier called Mandiant, about the Scattered Spider hacking group. They have been very active recently. And when they have been exfiltrating data from Salesforce, they have been using tools that already are used in those Salesforce orgs, especially ETL tools. So the report mentions two specific ones, Airbyte and Fivetran. So they've been seen using those tools because the organization is already using those tools, and they are SaaS platforms. So basically the connection is coming from the same IP address, from Fivetran's IP address, for instance, just from a different Fivetran account. But that Fivetran account is nowhere visible in the Salesforce logs. So they look identical, the real Fivetran connection and the attacker's Fivetran connection. This is called an evil twin attack, where the attacker is basically hiding in plain sight. So they are using the same services. They're not creating their own tools because that would look suspicious. And also it's actually difficult to create tools that export huge amounts of data from Salesforce. So they use the off-the-shelf SaaS services. So this is an example, and Scattered Spider is definitely a group that is in the news quite a bit, at least on the security side of the news at the moment. But it's also not necessary to do this thing very slowly from initial access to the lateral movement and then export the data. You can do all of this in a few minutes. And here is an example how this can happen, and this is actually a report from the same group, so Mandiant, Google Threat Intelligence from last week, about another group that they call UNC 6040, not as cool of a name as Scattered Spider, but anyhow, a very active group. Risky Business News said that they have done this to over 20 organizations already. So what they do, and they target Salesforce. What they do is that they do this attack through social engineering. They have been targeting international organizations, and they are clearly English-speaking actors. They call somebody from the victim organization over the phone, or maybe WhatsApp, something. But they call them and say that, I am from the company IT support, and we have a new ticketing system, you need to start using it. And then the victim says that, okay, what should I do? So then they say that, okay, you need to open your browser and go to Salesforce. Then you need to approve my prompt. And what happens there is that they get to the page where they have to enter an 8-digit code. And this 8-digit code is then provided on the call by the attacker. And anybody who's done anything in Salesforce recognizes probably this prompt, because this is the OAuth device flow, so the IoT device flow prompt that data loader from Salesforce uses. And actually the group is using data loader for doing this. So basically, they are asking over the phone call for the victim to authorize their data loader connection. And once they've done that, they immediately move to exporting the data with the data loader. So it's a couple of minutes of phone call, and then all the data is flowing out. No need to do all of this lateral movement and the challenging stuff. Very powerful, and at least I haven't figured out a way how to disable the IoT device flow in Salesforce. All right, we've talked about how the attacks work today in this app-centric world. So how will the agents change this world? Will it get easier or worse? I'm sure that you're already guessing what I'm going to say. But first thing to understand is that agents in Salesforce are not going to be all about Agentforce. So Salesforce is marketing Agentforce quite a lot, so it might feel like that, but there are other agents already, and there will be other agents in the future as well. Agentforce is accessing Salesforce and its APIs sort of directly, but the other agents are accessing Salesforce through two different means, either through the Salesforce APIs or then through the browser. With the APIs, the agents, as they do today, are usually accessing that API directly, but there is also a standard protocol now called MCP, so Model Context Protocol, which makes it much easier to integrate with SaaS services, including Salesforce. And hence, it's quite likely that a lot of these agents are actually going to be connecting into Salesforce through an MCP server, which then connects to the API, so that they don't have to implement the interface with Salesforce themselves. But anyhow, the agents are talking to the APIs. But there is another development that started end of last year, which is that the agents can actually integrate with Salesforce through the web browser. And this is something that Anthropic calls computer use, and OpenAI calls it operator. So it's essentially a virtualized browser, and you give it your Salesforce credentials, and it will browse around in your Salesforce through the web browser and figure out what it can do, and will do what you ask. So I think you can implement it either way, but they need but it needs access to the browser. API only is not enough. So this means that not all the agents are coming through Agentforce. Not all the agents are even coming through the API. Some of them might be actually looking like a normal user browser session. The user just has asked ChatGPT that, hey, can you go into my Salesforce and do these sort of things for me? And this is, of course, very convenient for the user, but everybody who manages Salesforce will understand that, okay, this might bring some challenges. Because there is a skills barrier to human users. They will only do things that they know how to do. Also, usually they have some common sense, and they will do only things that they feel that they should do. AI doesn't have common sense. AI can do whatever. It doesn't have any skills barriers. So as long as it has access, there is a risk that it will actually go ahead and do it. So you hear these horror stories about Salesforce orgs where almost everybody is an admin. This can soon mean that every AI agent out there is an admin in the Salesforce orgs, and this can get into all kinds of problematic areas. In the agent world, you have a thing called guardrails. So you give guidelines to the agents of what they should be doing and what they shouldn't be doing, and you give this in natural language. But these are not security barriers, because like those, the AI might misunderstand those guardrails, or they might be written in the wrong way, or there might be some sort of a prompt injection type of a thing where somebody can convince the AI to disregard the guardrails. The real security barriers in Salesforce remain the exact same as they've been. So they are things like system permissions, things like sharing. Those need to be in check before we move into this agentic era, because agent guardrails are not security boundaries. Eventually, somebody will figure out a way how to bypass them. So it's the time to make sure that your Salesforce security controls are ready for this agentic era, and not just your data. All right, thank you. And next we will see this in action. We have a demo of the Valo product. So Valo helps you protect these security boundaries, but also to detect attacks against the more traditional threats as well. Mikko.
One addition, UNC 6040, which doesn't sound as cool as Scattered Spider. They have a cool name as well. This is the Shiny Hunters gang, which is the same gang which hacked Snowflake.
Okay, so according to Mikko, 6040 is also known as the Shiny Hunters. So that's definitely cooler as a name. Thank you. All right, time for the demo.
Okay, so thank you, Mika, for this really nice and insightful presentation on how can we keep our Salesforce secure, especially with agents and Agentforce coming with all the hype. I'm going to begin by introducing myself. Some of you already know me. For some of you, I'm a new face, so it's better to introduce myself. Hi, my name is Fatika. I'm the product manager at Valo. And today I'm going to tell you how we are helping our customers achieve success with Salesforce. And for that, I actually thought it would be a better idea to bring one of our customer success story in front of you. But before we do that, let's begin the story by telling you how are we actually helping our customers. So there are 3 things we help our customers with. First of all, Valo is continuously monitoring your apps and connections, so your Salesforce apps and connections, 24/7 hours for you. And if there are any security threats, or as Mika showed you, a lot of security threats do exist, if there are any of those things, we alert our users and we let them know how can they fix it. In some cases, we even go ahead and fix it for you, of course, after your consent. Secondly, we also help our customers reduce or optimize their Salesforce license costs. And we do this by showing you if you're using the right Salesforce licenses for the right people or for the right users. So we put your usage, your license usage, against the users that you have assigned those licenses to. But thirdly, that's the interesting area, and we're going to talk about the most today, is access controls. So Valo helps our users understand their access control structure, and then also helps you highlight some problems that you might not know exist there. And for that, actually, we have a success story in front of you. Yes, so here's our success story. Acme is one of our customers who has been using Valo for quite a while. They recently went through an acquisition where they were bought by another company, which meant there were a lot of changes going on within the organization, and those changes had to be reflected in their Salesforce as well. One use case where we helped them a lot was where they wanted the sales managers in their organization to only have access to the sales opportunities from their particular regions. So people in North America should only be able to access opportunities from North America, and people from EMEA should only be able to access opportunities from the EMEA region. They decided to do this by using criteria-based sharing rules in Salesforce, and Valo helped them visualize how their sharing structure was working, how access controls were working and actually highlighted quite a few problems with the access control structure as well. But it's better if you see it in practice. So if you see how we help them save time, help them reduce redundancy when it comes to permissions. And that's why we have Antti Norrkniivilä, our Valo super user, and also their Salesforce admin in Acme. So he's going to show you how Valo actually helped them.
All right. Thank you, Vatika, for the introduction. Excited to tell you what we have been using Valo for. And first, let me tell a bit more about the migration project that we actually did after the acquisition. So basically, what we did, we previously had this one sales division, and now with the acquisition, we divided that into 2 regional units. So one for EMEA, one for North America. And then we moved our Salesforce roles from these old roles to these new regional roles. So where we previously had roles like sales manager, now in the new structure, we will have sales manager EMEA and sales manager North America, and so on. You get the point. And then lastly, we used public groups and criteria-based sharing rules to restrict the record access. So we wanted to keep it so that people in both regions, the salespeople could access all the records from that region, but definitely not the other region. But then in this migration process, after making the changes, I also needed to test the changes. And previously, what I have done for this is that I will go to Salesforce, go over these permission sets, groups, sharing rules, and kind of do this like 3 times to just make sure that I understand how the accesses are set up. And then I will also maybe log in as some of my Salesforce users to kind of go and see what they are seeing. But this was not reliable because let's say that there are some issues. It doesn't really tell me what the issues are. But then actually here Valo comes to picture. So just when we were starting this testing phase, Valo and Vatika asked me if we at Acme, we wanted to pilot this new feature that they have been working on. So it was about exploring permissions and sharing visually. And I was definitely interested because this sounded like it's just what we need for the testing phase. So let's actually go ahead and see a short video of what I did in the process. So in the testing phase, I had this kind of checklist to kind of go through users from different roles and make sure that their accesses are set up correctly. So coming back to the previous slide, we had this 2 users. We have Mikko Manner and Laura Lindberg from Acme, who are both EMEA sales managers, who we used in this testing. So let's start this right here. So first what I did is that I asked about Mikko, the other sales manager, and kind of just this simple question. I didn't even need to include any Salesforce concepts, but just a simple question, what opportunities they can access. Valo builds this complex query and then visualizes these permissions and sharing for me. And this visualization already was a huge value add. But then what was even better were these insights on the right side of the screen. So in this case, Valo told that there is this GTM leadership group that actually grants sales managers access to opportunities of other regions as well. That was really good. But then I noticed also in Valo UI that it suggested that I can compare 2 users. So I did that. I compared Mikko to a colleague, Laura, who should have the same accesses. But now I actually detected something really alarming. Valo told me that Laura can actually modify all opportunities, including those from the American region. And that was due to this account manager permission set that granted her modify all opportunities access. So this was something that I also saw some other really cool insights like these overlapping permission sets. But then I wanted to dive deeper into what this account manager permission set actually was and who had access to that. So for that, I also just asked this one simple question: which users have it and what other permissions does it grant? And then I noticed that it's granted to 4 users. And I knew that 3 of these were actually account executives in Finland, and then this one sales manager from Finland. And they definitely should not have access to American opportunities. And then this kind of made me realize that this was technical debt from way back in our org, when we didn't yet use sharing. And this Valo just kind of helped me discover it and also then fix it. All right. After this one case that we used Valo for, here's kind of my summary. So with just a few simple questions, I was able to find these access settings that introduced both redundancy in my Salesforce environment, as well as also some critical security risks. And best part was that I didn't even have to memorize all these Salesforce concepts and kind of remember to go through all of them, but Valo was actually the one doing that for me with just a simple question. And now at Acme, we couldn't go back to managing accesses the old way without Valo, because with Valo we can make these changes faster, with more confidence, and actually instead of introducing new technical debt in the process, Valo actually helps us do the changes so that we actually reduce the technical debt. And all of this has just made our Salesforce org now much more adaptive to change, which is really crucial for us to keep up with whatever requirements our business keeps throwing at us. All right, thank you.